With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Okay, so the given question here we have is if imaginary part of 2z plus 1 divided by iz plus 1 equals to what? Minus of 2. Then the locus of z, this is what we have to find is. Okay, so first of all, I can say that here, this is my solution part, right? So what is the equation given to me in the question, which is what? Imaginary part of 2z plus 1 and divided by iz plus 1 equals to what? Minus of 2. So first of all, what I'll do, I'll take my z as what? I take my z as x plus I y. Okay, this is what we are going to take. So if z my x z equals what? X plus I y. So in that case, this equation imaginary part will become what? This can be done as here 2 times of z plus 1 divided by I z. Okay, and plus of 1. This equals what? Minus 2. Imaginary part is equals to what? Minus of 2. This is given to me in the question. So if I have to find the value of this 2z plus 1 and iz plus 1, I can write here that 2z plus 1 divided by iz plus 1. This is equals to what? This is basically equals to, if I put the value of z as x plus iy here, so this will be 2x plus iy, right? Plus of 1 divided by what? I x plus of I y, right? And plus of 1. No, so now this will become what? This can be done as here 2x plus of 2iy and plus of 1, right? Divided by what? This is ix and this is what? Plus of I square y and plus of what? 1. We know that I square value is basically what? Minus of 1. And also doing one thing, taking 2x and plus 1 written together in the numerator. So 2x plus 1, right? Here is what? Plus of 2iy. Okay, divide by, this will become, now this can be done as 1 minus y. 1 minus y. Okay, as this part is minus, so this will be 1 minus y and plus of ix. Okay, so plus of ix here I have. Now what I'll do, look carefully, I'm going to rationalize this term. If I rationalize this term in the denominator section, I can see that this is what? Plus of ix. So I can do only one thing, 1 minus y and here minus of ix, right? Again divide and multiply, so this will be 1 minus y minus of ix. You guys know how to rationalize things, right? So this equation we are going to receive, this will be what? Basically this thing we are going to receive as, I can write here 2x plus 1, okay, plus of 2iy. Okay, this section here with the product of this one y minus 1 minus y. Okay, minus of what? Ix here, and the denominator part is basically what? This is what? 1 minus y, 1 minus y. Okay, plus of ix, right? And this is what? 1 minus y and minus of what? Ix. Clearly we can see that this part is what? This part is my a plus b and a minus b. So this can be done as what? A square minus b square, right? So I can write here this part. So this can be done as what? Here, taking this part here. So this will be 2x. Okay, if I multiply this part here, so this will be 2x, right? Minus of what? 2xy. Okay, and then what? Minus of 2i and x square here I have. So this will be what? And this will be what now? 1. I'll do 1. Okay, so plus of 1 minus of what? Y and minus of what? Ix. So again this part is what? So plus of, okay, so basically 2iy, right? And what? Minus of 2iy square. And here what? Minus of, basically minus of 2i square xy. In the numerator part I have. And denominator, you guys know denominator is basically simple. How? A minus b and a plus b will be basically a square minus b square. So this part will be my 1 minus y whole square, I can say, right? Because this is what? 1 minus y whole square. This is my a part, suppose, and this is what my b part. Sorry, this is also a, this is what b part, this is what b part. So now a plus b, a minus b, and this part will be what? Plus of x square, y plus, because there is a I and I square will be what? Minus of 1. So minus minus will be plus. That's why I just write down it correctly, plus of x square. So clearly this part is, now you can see that 2x minus 2xy. Okay, so first of all what I'll do, I'll put imaginary part and real part again together. Okay, so if I write down real part first, so this will be what? This is my real part, 2x. Okay, so 2x I can write here. Also what? Minus of 2xy is also real, and minus of 2x square. So this is my imaginary part, and plus of 1, this is also real. Plus of 1 minus of y, this is also real, right? Minus of y imaginary again, this is imaginary again, this is what? Imaginary, this is what? Okay, so this is my positive of plus 2, right? Because I square is what? Minus of 1, so this can be done as plus of 2xy. Okay, now we are left with what? Imaginary terms here. So these are what? Minus of 2ix square, okay, and minus of ix, okay, and this is what? Plus of 2iy and minus of 2iy square, divided by what? Divided by the section area is what? 1 minus y whole square plus of x square. Okay, so now I can write here that my 2x minus 2xy, okay, minus y plus of 2xy. Okay, so first of all I can see that this 2xy and this 2xy are cancelling out with each other. So I can say that, so I can just write down here, as these two terms are cancelling out, this will become 2x plus of 1, or we can say first of all I can write minus of y, right? It will be more separated. So 2x minus y plus 1. Okay, divide by what? 1 minus y whole square plus of x square. I'm just dividing these imaginary part and real parts. Okay, and this here will be what? Okay, so this will be what? Plus of minus of 2x square. So if I take I common, so first of all I taking common, so this will be minus of 2x square. Okay, and this is what? Minus of x. Okay, and this is what? Plus of 2y, so plus of 2y, and then I have what? Minus of 2y square. So minus of 2y square divided by, again, divided by 1 minus y whole square plus x square. Right now you guys will know why I did this part, why I divided this section into this one. Given question says that my imaginary part of this term, right? We are expanding only this term right now, only this term, right? So imaginary part of this term is basically equals to minus of 2. So now I can say that which part is equals to minus 2? This part. This part is basically equals to minus of 2. So I can write here that minus of 2x square minus of x plus 2y minus of 2y square divided by what? 1 minus y whole square plus x square equals to what? Minus of 2, right? So now I will expand it. So this will become minus of 2x square minus of x plus 2y minus 2y square equals to, basically, this is this can be done as x square plus 1 minus y whole square, right? 1 minus y whole square with the product of what? Minus of 2. Okay, here my minus of 2 here I have. So this can be done as what? This can be done as minus of 2x square minus of x and plus of what? 2y minus of 2y square. Okay, this is what? This can be done as here. Multiply minus 2 here, so this will be what? Minus of 2x square. So minus of 2x square and minus of 2. Okay, there is a product of 1 minus y whole square. If I open it, this will be what? This will be 1 plus of what? Y square plus of y square minus of 2y, right? So now this can be done as what? This can be done as minus of 2x square minus of x plus 2y minus of 2y square. Okay, this is equals to what? Minus of 2x square minus of 2 minus of 2y square and plus of what? 4y. Clearly we can see that this term cancelling out with this one and this one is cancelling out with this one. So we are left with what? Terms of x and y having single power. So this equation will become, this can be done as minus of x. Okay, so plus 2y, this 4y, if I put this on the LHS side, this will be minus of 4y. So this will be, I can write here minus of 2y is equals to what? Minus of 2. Taking minus common, this equation is what? X plus 2y equals to what? 2. And clearly this is my locus we are looking for, and this is locus is the straight line. This is my straight line here I have. So this is my straight line locus. So if I go to the top, I can say that which option is correct. Exactly, my option number 3 is the correct answer we are looking for.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.